So welcome to 9.7. Turns out you can write square roots and cube roots as fractions. So square root of 25 is 5. Square root of 25 squared, those cancel out, and that's 25, right? That's not 5, right? Because you could actually figure this out. The square root of 25 is 5, and then 5 squared is 25. Square root of 25 cubed, well, that would be 5 cubed, which would be 125. Okay, and let's remember when we're doing square roots, there's a little 2 there, right? Cube roots have the 3 there for us, so the cube root of 27, right, blank times blank times blank equals 27. The only thing that can go in there, the cube root of 27 is 3. So the cube root of 27 squared, cube root of 27, 3 squared, 9. Cube root of 27 cubed is 3 cubed, 3 times 3 times 3, 27. So cube roots cancel each other out with cubes. Interesting. All right, so look at this wackiness. Yes. All right, square roots can be written as a 1/2 fraction exponents. Cube roots can be written as a 1/3, and obviously fourth roots would be to the 1/4. Yes, and we'll see why that works today. So the 36 to the 1/2 is the same thing as the square root of 36, 6. 25 to the 1/3 is the same as the cube root of 125. Did I say it's 125 to the 1/3 to the cube root of 125, which is 5. All right, so if we have to assume x is positive here, no negative numbers inside our square roots because we'd be imaginary. And so let's look. We're going to rewrite this with fraction exponents. You could rewrite that as 81 to the 1/4 power. So we fraction it, right? Negative exponents made fractions. Fraction exponents make roots. So that is the same as 25 to the 1/2. All right? We're rewriting it. Yes, it's 5. And this is 125 to the 1/3. All right, so now evaluate. So let's see. 100 to the 1/2 is the same as the square root of 100, 10. 343 to the 1/3 is the same as cube root of 343. So blank times blank times blank. Now remember, I memorized that 5 times 5 times 5 is 125, right? So, and I've said I wouldn't give you anything bigger than 10. So this has to be 6, 7, 8, 9, or 10. Well, it's definitely not 10, so it's 6, 7, 8, or 9. Let's try 7. 7 times 7 is 49, times another 7. Well, that ends in a 3. That's a good sign. 7 times 4, 28, plus 6. Yep, the cube root of 343 is 7, and 343 to the 1/3 is 7. 64 to the 1/2, that's the square root of 64, which is 8. 64 to the 1/3 is the cube root of 64. Blank times blank times blank is 64, right? It has to be 4, yeah. So 64 is both a perfect square, because it has a square root that comes out as a whole number, and a perfect cube, because it has a cube root that comes out as a whole number. Right? This is always true in math. The rules never, we rarely say the word exception in math. It's when usually with something with 0, right? So we can add those exponents, right? So what's 1/2 plus 1/2? 1. So this is x. X to the 1, right? The square, so it turns out the square root of x times the square root of x equals x. Well, yeah, because the square root of x squared, right? Those cancel each other out and you get x. So that's the same thing, is it not? That's x to the 1/2 times x to the 1/2, right? Or we could multiply 1/2 times 2. That's still x, right? So that's the square root of x squared again. They cancel each other out. All right, so let's see. Y to the 1/3 cubed. That's y to the 1/3 times y to the 1/3 times y to the 1/3. What's 1/3 plus 1/3 plus 1/3? 3/3. This is y to the first, y. So I guess cube roots and cube cancel each other out. What do you have if you have the same thing top and bottom, right? You you subtract the exponents here, this is y to the 0, 1 whole. All right, so, we've already talked about this canceling out, but y, power to the power problems, so let's just write a power to the power problems. Y to the 1/2, we showed this. You multiply 1/2 times 2, you get y to the first, y. So what about that? Or what is that? X cubed. Well, what if I write it like this? X to the 1/3 squared. Well, that must equal x to the 2/3, right? Because x to the 1/3 times x to the 1/3 is x to the 2/3. What the heck is x to the 2/3? Guess what? It's the cube root of x squared. Yeah, would you rather say x to the 2/3? I would. So that's x squared of x to the 5th power. So what's that? X to the 1/2 to the 5th power. 1/2 times 5. That's x to the 5/2. Don't make it a mixed number. Don't make it 2.5. That's x to the 5/2. What is x to the 5/2? It's the square root of x to the 5th power. That's what it is. So the bottom of your fraction is your root. When we had 1/3, it was a cube root. When you had 1/2, it was a square root. The bottom is your root, and the top, the numerator, is your power. Okay, saying what I just said. So 625 to the 4th root cubed can be written as 625 to the 3/4. All right, so this thing is the square root of 4 to the 5th. Well, we know the square root of 4, 2. So 2 to the 5th is 2, because we're evaluating. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 27 to the 2/3 is the cube root of 27, all of that squared. Cube root of 27, we did in the warm-up, is 3. 3 squared is 9. This is the square root of 100 cubed, right? So the denominator is your root, the numerator is your power. Square root of 100 is 10. 10 cubed is 10 times 10 is 100 times 10 is 1,000. All right, so we can multiply 1/2 times 4. 1/2 times 4 is 2. This is 81, right? You could also write it out the long way if you don't want to do it that way. What's 1/2 plus 1/2 plus 1/2, right? That's 9 squared. 1/2 plus 1/2 is 1, plus another half, 1.5, plus another half, 2. So this is 16 to the 2/4. We simplify your fractions, 16 to the 1/2. Well, that's the square root of 16. The square root of 16 is 4. Yeah. So what does that question mark have to be to make that? Well, it has to be 1/2, right? The only way, right, we're going to get x to the first is if the question mark is 1/2. So what does the question mark have to be here? X to the 1/4. This has to be a 4, right? So the question mark is 4. So let's practice all this. 49 to the 1/2 is 7, right? Because that's the square root of 49. 8 to the 1/3 is the cube root of 8, which is 2. This is the square root of 25 cubed. Square root of 25 is 5. 5 cubed, 125. This is the square root of 100 to the 5th power. Square root of 100 is 10. 10 to the 5th power. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. This is the cube root of 216 squared. Well, the cube root of 216, all right, remember, the cube root of 125 is 5, so it's more than 5. I think we did 343 was 7, so this is 6, I think. 6 times 6 is 36, times 6 is 216. So cube root of 216 is 6, then we have to square it. 6 squared is 36. 5 to the 1/2. 1/2 times 4 is, right, 4 halves or 2. 5 squared, that's 25. All right, so simplify that. That's x to the 1/2 times 4, which is x to the 4 halves, which is x squared, right? 4 over 2 is 2, right? That's, add the exponents, you get y. So what does the question mark here have to be? The question mark has to be 1/3. That's a wacky one. What is that? That is x cubed, the cube root of x cubed. Right, so the question mark had to be 1/3, right? If the one, I didn't really do a lot with 1/3 fractions out there, did I? So this one is the square root of 64 cubed. This one is the cube root of 64 squared. Let's see. Square root of 64, 8. 8 cubed, 8 times 8 is 64 times 8. 64 times 8, 32, 512. Cube root of 64 is 4, right? Because 4 times 4 is 16 times 16 is 4. 4 squared. This one's only 16. All right, so they're not the same answer. You can't just flip them over. All right. Good luck with the homework.